We've talked about this already, but you might need that again. But just sit down now. So the letters being used are not always going to be X and Y. Okay, so they have been up until now because we've been talking about the change in Y over the change in X, and that talks about the gradient. Okay, so if you're talking about a function and gradient, then it's always going to be X and Y, okay, or Fx and X. Blah, blah, blah. The derivative is finding the rate of change of something. Okay, so as I've said, the rate of change of y as the value of x changes would be known as dy dx. If we had some other kind of expression, for example this, what's this formula? A equals pi r squared.
Area
of a circle. Okay, oh, it tells you. So the A equals pi r squared tells us the area of a circle with radius r. So if we wanted to know the rate at which the area changes with respect to the radius, then we would find dA dr, and we would differentiate it. So the rules of differentiating do not change depending on what we're looking at. Is pi a variable or a constant thing?
constant.
Yes. Okay, so that's always going to be the same, yes? So we imagine that that's a number. Okay, the only variables are the A and the R here. So if we were trying to find dA dr, how would I do that?
You put
Don't rush at once. What's the rule? How do we differentiate?
pi r.
Done.
Oh wow, that's fun.
Okay, power comes in front. Take one off the power. Yes?
Isn't that the?
That is the formula for the circle.
Yeah, that's cute.
Okay, so the rate at which the area changes is the same as the formula. But the important thing is here that you recognize that the process of differentiation does not change whether the letters are Y's and X's or anything. Okay, you all happy with that? So if you ever see the phrase rate of change, you're going to be differentiating. Now, there's only usually two types that you see. Either the gradients that we've been looking at, okay, or this next topic. You may or may not have heard about this in physics.
Kinetic energy.
So, kinematics looks at the study of movement, okay, and we use calculus to link the distance, the speed, and the acceleration of an object, and they're all with respect to time. Okay, so what happens here is you may have an expression for distance, or officially it should be displacement, and so that would be in terms of time. You may have an expression for speed, which is in terms of time, or acceleration, which is in terms of time. Okay. Now, distance or displacement, perhaps we should write that here just in case we see it some other time. Displacement is assigned the letter S. No, I have no idea why. Okay. Speed, officially, we're looking at velocity. This one is understandable. This is V. And acceleration is assigned the letter A. Okay, so we've got S, we've got V, we've got A. As I've said, they're all going to be given to you in terms of time. So it could be, for example, S equals 3t squared plus 7. Okay, it could be that A equals 5t minus 2. It could be anything. Okay, but the letter that they're using will always be T because it's always going to be time. Here's an example. So S equals t cubed minus 4t plus 5. So if we wanted to find the displacement or distance that a particle travelled, you would cube t, you'd subtract 4 lots of t, and add 5 to it. Okay? Remember, t is the time that we're talking about. Why is she rambling on about all this? Well, because, as I said, calculus is used to link these three aspects together. S, if we have an expression for S, we can differentiate that in order to find an expression for the speed or velocity. So if we differentiated S, we would have ds dt. Okay, so S would differentiate to dSdt, which we're saying is equal to the velocity. Now, that velocity would differentiate to give an expression for acceleration. So, we haven't talked about second derivatives, so I'm not going to confuse the matter. So, dv dt would be equal to A.
Is that an S over?
This ds dt,
Over
I was just underlining S.
Over D.
And so if we're given an expression for distance, and if we're asked to then talk about the speed of something, we would differentiate it. Okay? And then usually it involves substituting in a value for t. Alex is trying to stop doing that, okay? Here's an example for us. So the distance, why do we think this m is here?
Meters.
Okay, good. I asked that on purpose because sometimes it throws people all the dinner. Okay, so the distance in meters of a particle is given by this. Sometimes this would be written like this. We should be familiar with stuff like that. It just means it's an expression for S in terms of t. Okay, don't get suckered in by thinking you're supposed to do something with this here. Okay, it's just S, it's just a name for it. So we need to find the speed after 4 seconds. Well, we've been given an expression for displacement or distance. They're talking about speed, so we know we have to differentiate it. So first thing we're going to do is find ds dt. Okay, so ds dt would be, Samantha, what?
3. Oh no, minus.
Good. Awesome, you all happy with that? Power comes in front, take one off the power, and when there's just a letter, it's just the number in front of it. Well, they've asked us to find that speed after 4 seconds. So all we need to do is substitute that value in. So ds dt at 4 seconds would be 3 lots of 4 squared minus, so 3 lots of 16. Remember, we must always follow their maths when we're doing calculations. 3 lots of 16 is 16, darling. 3 lots of 16.
48.
Minus 4 is... Okay. In order to know what units... Oh my, keep yarns, I need to fell over. In order to know what units we're talking about, we would need to make sure that we look back at our original question. This is meters, and they're talking about seconds, so we would have meters per second. So, here's the situation with calculus. Majority of the questions will just be looking at gradients and gradient functions. You're only ever likely to have one question on calculus. It could be a tiny one worth 2 or 3 marks. It could be a more substantial one where they're talking about turning points. Okay? Or you may have a question just on kinematics. Okay? So if you've got to the end of both papers and thought, oh, I didn't have a question on calculus, and they start talking somewhere about speed and displacement or acceleration, that's the calculus question. Okay? Now, I'm not saying it's always going to be on paper 2, because it could be on paper 1. But please look out for these. For them, paper 1, paper 2, there's no difference whatsoever. It's just that they cannot fit it all in on one paper.
So
It doesn't mean that paper 1 is easier. We have no idea. No, we've none of us do. But I was just saying, oh, that's what we'll put it. I was just saying to Emma, I think, when you come, oh no, it doesn't matter. It doesn't matter what I'm saying. When you come out of paper 1, okay, you should jot down the topics that have been in your exam, right? That will mean that if, for example, there was a cumulative frequency graph question on paper 1, there is not going to be one on paper 2. If there was a solving equation question on paper 1, there will be some on paper 2 as well. So there are certain topics that they do repeat, but there are a majority of them, it's a one and done. Okay, they've asked you it, they've tested it, they're going to move on to all the other stuff. Okay. What I don't want you to do is come out of an exam and go, oh my god, these things I couldn't remember. That's not what I'm asking you to do. It's just jot down the topics. Okay, so again, if there were percentages questions on paper 1, there's likely to be percentages questions on paper 2, but it would be of a different type. So if there was a percentage change on question 1, then maybe a percentage increase or decrease on paper 2. That's the kind of thing to think about.
Because you get to see the text, right?
Only 24 hours after you do. So depending on the timetable.
It's not yet. So would you be able to tell us what?
You want me to do the hard work?
Tell us what topics are on the test? Is that what you're saying? Yeah, so like tell us what
We'll see.
Because we don't get to see those things, so we might not.
We'll see. Although, like, we do have things like other lessons and stuff the same.
Everyone younger than you 11?
We have to teach other people. Our job is not done once she's on 30. Now, I need to talk to Miss Latham. We may decide to give you a helping hand for the mock paper to let you know which topics are on which paper, but I'm not saying for sure we're going to. Okay, so we need to just start to discuss that.
What is it? I don't know. Like,
Hang on.
how many questions are there?
There's usually between 19 and 22 or 23 questions on each paper. Okay, but obviously there's A, B, C, Ds in most of them. Okay, but you have your calculator available for everything. You can take both your calculators in, and all of these things. Now, I'm hoping that we will finish a good chunk of this stuff before the mock, so that we can give you a mock paper that's as realistic as possible. Excuse me. It may be that we include some questions that are not going to be marked. Okay. So, for example, if we haven't done a topic, but we want you to see what kind of question might come up, feel free to have a go at it, even if we haven't officially gone through it yet. But that won't be counted in the mark allocation. Okay. Yep.
By A, B, C, D, do you mean like multiple choice?
No, they're like part A, part B, part C.
Like I.
Or even AI, B, I. Yep.
Will you tell us, like, in a question, if this question is not going to be counted?
No, I'm going to make you guess. Yes, it will be very clear at the top, but that doesn't mean anything because you lot tend to just ignore any instructions anyway. Okay? But it will be said at the top of the page that it's not going to be included. Okay? I don't want to cross it out because if you want to have a go at it, I want you to be able to read it as well. Okay? Anything else? Because I'm just gas bagging and we're recording all this. Alright.